My name is Jens. I'm a software developer at Partisia. I mainly work with the smart contract language, where I'm mostly developing the new integration test framework we are developing, so it will be easier to do testing on the smart contract. So first off, what is a smart contract? I just did analysis trick and did a little Wikipedia search where the definition of the smart contract was theorized long ago, where it says that it would be very nice if we could have this computer program where even a transactional protocol or anything could be fully automatic and final execution. I just want to make sure that everybody knows that this is not exactly how it works on a blockchain. So one of the things we need to think about with smart contracts on the blockchain is that every contract has a single unified state when it's deployed. We can interact with the state through actions. However, these actions are not fully automatic in any way. Somebody has to start a call process, and you have to have a chain of calls between contracts for automatic behavior to happen. But somebody has to call from the start. So another thing is, when we are doing interaction with the state of the contract, another thing to note is that when an execution of the action has happened, this execution is final and is irreversible. You can call another action that reverses the behavior, but again, it is on the chain that we have. So this has already been confirmed for the community. So that has happened and it cannot be changed. Good. So the reason for my talk is that we would like to be able to test these smart contracts and be sure that are not holes, because if behavior can be exploited or a token can be transferred to the wrong parties, it's final. We cannot reverse it unless we branch off and make our own chain in this behavior. So these holes are quite expensive. There are a lot of examples of smart contracts that have been exploited because there has been some form of oversight in the behavior of the contract. There is something like the Arco project or the film where it unfortunately locked. It was not even somebody who took it, it was just a contract that ended up in a locked state. We have Scheel finance where the treasury just got drained because there was illicit behavior defining the contract and nobody had tested. We have all these different kinds of problems that could have been solved or maybe discovered throughout the testing process of the smart contract. However, testing smart contracts is not only sometimes very hard, depending on the smart contract framework you're using. It can also be quite tedious if the only way to do it is by manual testing. However, we have all these different kinds of ways of making certain that whatever code I write in the smart contract becomes the correct behavior, and I know that this is the behavior. One of the ways that I can do this is that by having other peer review my code and making it such that other people have read it and also says, oh, I think it does what it's supposed to do, then we can start to have this process of be certain in the behavior. If I also write some documentation that other people can write, they can say, read my documentation and say, I understand it like this, but your behavior is different. What is it? Why is it that you are saying it does it transfers the tokens to the sender instead and not to the receiver? Why are you doing all these kinds of things? And we can also make sure that we're testing our code properly by having a test framework and a test suite that hits all of the code that is in a smart contract. This way we also know that we have not only executed parts of the code, but we have executed all of the codes in some of the tests. This does not mean that we have tested every single branch of behavior. However, it means that we have executed lines of code that should not be able to be hit by other people unless it's through the actions that we have also taken. And one of the last things we can do is we can define our smart contract behavior in a type-safe language, where we have the static type checking of the types such that we know the sizes of objects, structs, and other RPC parameters cannot access illegal memory and these things. So that's some of the things we can do. However, we can do more. We can start writing a lot of tests and doing a lot of behavioral assertions in these tests. So I like to have this ladder, which is how certain are we that the behavior defined in our contract is the one that we think is happening. And the first level is happy and lucky. You are very happy because you didn't have to write tests. You're very lucky if the behavior is what you wanted, or just a very, very good programmer who can see every single branching incident with all of the interacting contracts. The next step we can start doing unit testing. Unit testing is where we test single parts of the code. Here in the test of the smart contracts, that will be testing the actions, testing that the functions we have defined on our state actually does what it's meant to do if we give them the input we expect the blockchain to use. So I'm going to go through this example where I'm going to show you some of the tests that you can do. And then, yeah, you're going to see. So first off, we have a simple auction contract. I have some token, I want to sell something off, and I want people to bid with my bidding token. We have the auction contract that starts, you can bid, and then you can claim if you didn't win the contract, and then you can end the contract where the people who have, the one who bid the highest receives the selling token, and the seller receives the bidding token. Okay? Great. So the first we can do manual testing. Manual testing is done on the Partisia blockchain through our testnet, where you interact with the contract you deployed on the testnet, where you deploy the contract, and then you can interact with it by choosing an action you want to send, and you put in the RPC parameters you need. RPC, by the way, stands for remote procedure call for everybody else. So let's try and do that. So I've deployed an auction contract. It's a bit small, but you can see here that we have a contract address people can interact with. And we would like to test that if I do a bid, I end up as the highest bidder in the state of the contract. So now I'm going to do I'm going to send a bid. I am going to bid, I think that's 100,000. 100,000 Ethereum or something for 1 million Bitcoins, let's say that. So I send my bid as the sender. My address is 0085 here. And now I can assert into the state that I'm looking at for the contract that, oh, I actually end up with the highest bid. And the highest bid is 100,000, that's my address for it. Now I want to assert that if I do another bid from another account, that account ends up with the highest bid. So again, we'll use a new account. We create a new bid and we send that to the testnet. And then I go back and check on my contract and see that now my address has become the highest bidder and the correct amount. Great. I have asserted that the highest bidder will be over if I send a new bid. Manual testing is really nice in this way because it's very easy for people to interact with your smart contracts and see behavior unfold. Run on the testnet, which is just a new deployment of the Partisia blockchain, so you can actually interact how it would be in the environment for the smart contract. This is great. This means that the behavior of the contract in the environment will be the same when you interact this way for the manual testing. It's great. It behaves like mainnet. That's just what we want. However, there's a lot where I have to input values and I have to deploy contracts and all this. It's very good to quickly assert behavior at the start, but when I'm continuously doing integration for my smart contracts, I would like to have some form of repeating tests that are easy to do without me deploying two token contracts, one auction contract, creating 4 accounts. No, no thank you. So what can we do instead to test each of the file and do it a bit more automatically? We can start writing Rust unit tests. So the way this works is that we are creating the context for which an action should be run. We call the context, call the action with the context of it, and the RPC parameters, and then we assert on the end state of it. So this It's a unit test where I omitted some of the byte code because that's not very interesting for anybody. But as you can see, first off, we have some setup where I create the context of the contract. I have some initial. This will also be provided. But I have some initial info. I have the initial deployment of the contract in the state. I create my address for the bidder, and then I create the context later. Now I assert, after I had called this action bid, now I assert that it calls the action, and the event that should be created, for which is escrowing my tokens for the auction contract, is actually happening. So we can see that the events that should have been deployed, should have been sent from this contract is also linked one. Now I go on and I say, this bid event, now I actually want to see what happens when I get all this, when the tokens are escrowed. And I want to update my state within the state object, so I get a callback which changes the state of my auction contract, and this way, and now I've done exactly the same as I did in the first step and the main net, the test net, but I've done it in Rust, where I have created a context of what it should be, of how I think the parameter should be to the function, and I have ended up asserting that I am creating the correct events this way. So this is something I can continuously run whenever I make changes to my contract. It's great. If suddenly I change some behavior inside that means I send two events instead. This test breaks and I need to assert why have this test case gone down and what is the behavioral change for my contract. This is a great way for us to create less overhead for the developer, just so you can be sure of the behavior of the smart contract. So, however, there's always pros and cons for things, but Rust unit test is nice, it's automated, it's all this. We test the source code directly where it is with the Rust, in the Rust project, and we can actually do coverage for a Rust contract this way throughout. That's just a normal Rust toolchain you can use for this. But you have to replicate everything for all of the options. All of the contracts, all of the actions, you have to do all this all this input defined in the test. So it's still not as great because now we lost something that the test had. It had a deployment, it had a blockchain we interact with. So back to our little drawing, what is the next thing? Integration testing, where we can have multiple contracts deployed on some chain, but we still want the automated part of the unit testing in Rust. So how would that work? So what we're working on is doing is this framework where we have an in-trust blockchain where you can deploy contracts. And all of these contracts you can send action as with function calls into this framework, and the framework handles it. And now you can say, I want the state of the auction contract and get it back. And from this you can begin to do assertion on the auction contract. This is also great because when we then start to have multiple contracts interacting with each other and I want to do thousands of transactions and see if this can create illicit behavior, we can actually create these tests as automated tests written in the code, have all of these actions sent, and we can assert back from the state for all of the contracts deployed. And this way we can begin to write a larger test suite for covering our smart contracts and all the branching and interactions between them. This helps us defining better behavior for our smart contracts and less unfortunate bugs. So one of the great things about this is that it's automated. We can also begin to factor in all of these different blockchain specific things like gas, interaction, deployment of the contract. Also, when you have a contract like this, you also want people to be able to deploy it in some other way maybe, or you want to be able to quickly deploy it again and make sure that when you deploy it, there's no failures in it, because it would be very, very unfortunate that you spend a lot of money to deploy some contract or spend some amount of money to deploy the contract and then it fails because you forgot the zero at the end or something like this. So you can also make negative testing, which is great. And also you have this way of interacting with the governance layer, where you can see token contracts, all of the account plugins, where you can also assert on these states if your contract is working with it. Again, it's great, you can actually look at the state of it and how it would be on the real blockchain, on mainnet. So this is what we're working on. The tests are going to be written in JUnit because the blockchain is in Java. So it's going to be, you write your test in Rust. You have your Rust test for all the behavior where you think it should be within the output. Then you go and you write a Java test where you interact with it as a normal Java object, contract, where you can assert the states and use assertions this neat way. But you can use it as continuous integration, and it's part of JUnit, so it's really easy to set up. It's easy to use, and we're working on making code coverage for the Rust contracts. So, such that when you're running both the Rust code, you can have code coverage 100%, but you can also have 100% interactive code coverage. So this way we are defining different layers of behavioral security for us, such that we are getting even more certain about what we end up with. So there's one more step, however. Form verification. Where you prove every single state for every single contract, and you prove it with all of the states possible, and you define a lot of different things. Form verification is very hard to do for blockchains because you have so many states, and the state explosion for doing just any form of blockchain is so hard. So what we can do, however, is we can begin to prove smaller parts of the contracts, and that's definitely something we're looking into, but that is also something that researchers at Partisia are looking into, so that's great. However, this you can do now. We're working on getting people able to do this. Maybe. If you want any further reading or material, you can go into the Partisia blockchain foundation where you can read about how you can compile the contract, and you will also find the programmer's guide that explains how you can, with an example contract, how you can write it. Yeah. Thank you.